Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Extension Digital Agriculture team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agriculture industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
Hello, FarmBits followers and first-time listeners. Welcome to the FarmBits podcast. I'm Taylor Cross.
And I'm Jackson Stansel, and we're excited to have you join us for this episode as we continue on in our Spring 2022 series covering autonomy and robotics in crop and livestock production.
We welcome two guests with us today, UNL's own Dr. Santosh Pitla and Utah State Dr. Sierra Young, to this episode of the FarmBits podcast.
Both of these professors have had multiple years of experience in research surrounding autonomous solutions and robotics in the agriculture industry.
In this episode, we discuss Dr. Pitla and Dr. Young's research projects utilizing autonomy, the advancements in robotics within agriculture, and the expansion of these solutions in industry.
With that background, let's jump into our interview with these two outstanding professors and research specialists.
So I started my undergrad in mechanical back in India, and then I went to Kentucky, got my PhD in agriculture engineering. And after that, I went to Ohio State for 1 year as a postdoc. And I came to UNL in 2014, and I do research and teaching both in mechanized systems management and ag engineering programs. Since 2014, I have been focusing on autonomous vehicles and robotic systems, primarily for row crop production.
Awesome. And Dr. Young, how about you?
Yeah, so I had a meandering path to ag engineering. I actually did structural engineering as an undergrad and then wanted to kind of switch my field. And that's why I pursued grad school. Started off in, all my degrees are in civil and environmental engineering, kind of looking at sustainability, but ended up getting into the use of UAVs or drones and aquatic vehicles for understanding the environment, and saw a lot of opportunity in agriculture and pursued positions in ag engineering, kind of the intersection between ag and biological and environmental systems, and did all my graduate work at the University of Illinois, spent a year or two at Iowa State University in their biosystems and ag engineering department, and then 3 years at North Carolina State University, and now I've been at Utah State for about a month.
Wow.
Working in environmental field robotics, again, kind of environment and ag applications.
Very cool. It's interesting that both of you kind of are coming into this whole thing from outside of an agricultural background, which I think offers some good perspective. And you probably have good perspective on the next question that we wanted to ask, which is, what is your favorite project in the past that you have worked on? And maybe this time we'll start with Dr. Young.
Yeah, that's a tough question because a lot of the projects are so different, and they're all quite fun for different reasons. Probably a favorite project is actually still ongoing, working with my doctoral student who's still at North Carolina State. And he's developing a UAV, an occupied area vehicle for towards autonomous pollination, controlled pollinations in the forestry industry. So it's kind of exciting because I think we're one of the first groups to kind of try to build this type of platform, and really starting from the ground up, developing new systems, integrating them with the platform, scaling up from lab to field studies. So it's kind of been a overarching project from really concept through development, and still ongoing. So that's been really exciting.
That is extremely interesting. What about you, Dr. Pitla?
Yeah, I think just like Sierra, many projects, but if I have to pick one, it has to be our current project on a FlexRow robotic vehicle. So it's a 60 horsepower robotic vehicle. It's just like fascinating to see it go through the row crops and collecting images autonomously. But also we have plans to do a lot more operations with it. So it's a very modular platform. So if I have to pick that, that's the one. That's a very special project for me.
Sure.
That's really cool. So I know Dr. Young kind of mentioned coming in from a different area into agriculture, what kind of sparked your interest, but would you, both of y'all just share maybe like what kind of sparked your interest into going into like specifically like autonomy and robotics in agriculture? Was there like a moment that you were like, oh, this is pretty cool?
Yeah. So Yeah, when I started my master's in Kentucky, I started in mechanical engineering. But then I got an opportunity to visit the ag engineering department, and I was just fascinated with how much technology used in U.S. agriculture. Because coming from India, so I didn't do much in agriculture. It was more mechanical and cars and automotive sector. But when I came to the US, I was just fascinated with the amount of sensors and controls and computing that is used in agriculture. So that really attracted me to get into this field. Yeah.
Cool. And Dr. Young, is there a specific event that kind of triggered your interest into autonomy?
Yeah, it was definitely a project where we were using UAVs and surface vehicles for data collection in an agriculture intensive watershed. So doing more surface water investigations, but all of this was kind of very closely tied to agriculture activity. And so that sparked my interest in field robotics. And then in grad school, I was in a different department, but had an opportunity to work on a project that we were developing a ground-based vehicle for phenotyping. And so I kind of had the field robotics experience and seeing, being in an agricultural field for the first time, looking at all the, it looks simple, but really it's quite complex, and all the opportunities and challenges associated with developing machinery, operating in those types of conditions, working with the data. It was just really interesting. And I was like, oh, I want to keep doing this. I found it, a lot of opportunity, a lot of challenges. It was exciting. Every day was different. So I kind of fell in love with that application of kind of the tools and technologies that I was using in a different way.
Very cool. Yeah, it's so interesting, all the different applications that are out there. And I think all the complexity that comes with each, individual application of autonomy and robotics. And I think that's one of the reasons why we really wanted to address this topic on the FarmBits podcast this spring, is the main focus of our series. But another thing that we've been wanting to focus on here this spring on the FarmBits podcast has kind of been diversity within agriculture. And so we have an initiative right now with the Women in Agriculture group here at the University of Nebraska to feature a couple of female ag entrepreneurs from the state on the podcast this spring. But one question that I also want to ask both of you, kind of being maybe, not exactly what you would expect to be the traditional individual who's working on tech in ag. Were there any challenges that you faced maybe as a female engineer, Dr. Young or Dr. Pitla, coming from India and maybe, being more of a minority representative within the agriculture industry? I'd love to hear, a little bit more about your experiences getting to where you are now. Dr. Young, we'll start with you, I guess here.
Sure. Yeah, I guess there haven't been specific events that I can think of that were like, this was a barrier, but I guess just generally thinking about my experience, it's the most obvious and ongoing thing is just kind of looking around and noticing that you're one of a very small number of women or minority agricultural engineers, and if not sometimes the only, which can be kind of an intimidating feeling. But I think I've been very, very lucky, and I've been able to surround myself with really supportive colleagues in the space. I think it's growing, and there's a lot of attention and a lot of folks kind of entering, getting involved in this space. And that's been, myself included, and that's been really exciting. And also being able to find community, as you mentioned, women in ag. I was very involved with Society of Women Engineers. You can kind of see other successful people working in the spaces that you're in. Has been kind of, and having really supportive advisors throughout my career, encouraging me to do things that maybe I didn't think I would. So that's kind of been, there's challenges there, but I think there's been a lot of positive outcome and a lot of, changes for the better in terms of representation and involvement, with some ways to go. But I think things are going in a good direction.
It's very encouraging.
Yeah, I definitely have been in NC State's lab, in the welding lab, one of the, only 2 girls in the class. It does get intimidating every now and then. So
yep.
It's very important to surround yourself with good people. Dr. Pitla, do you want to share?
Yeah, for me, it's just the scale of agriculture, right? The Midwestern agriculture that's something I've never seen before, right? So if you, back in India, 3 or 4 acres of crop, and primarily rice and sugar cane, those are the crops you're used to see. And there's maize too. But I started my grad program in Kentucky, right? So it was an eye opener for me. The Midwestern row crop systems. So if I have to identify some challenges, the big thing was, so how do Midwestern farming work? What are the planting seasons? So what are the cultural practices? So I had to do a lot of background work to understand how things work before I could actually start looking into the research.
Sure.
So it's been a great journey. I learned so much because of all the support I got from my former advisors and colleagues. So
that's really interesting. And talking to some of our other like Indian graduate students and students from like Southeast Asia, they've said the same thing that, it's just so new kind of coming into this like commodity row crop agriculture system here that is, I mean, you're used to small shareholder farmers, right? And the challenges that they face, but here it's a totally different ballgame in terms of technology use and then what the corresponding challenges are, I guess. So,
Yeah. So seeing, that larger agriculture, what are kind of some defining problems that Dr. Pitla, you might think autonomy could solve, and then Dr. Young, some robotics that could solve even in water management and such. And so I think we'll start with Dr. Pitla this time.
Yeah, so I think in terms of row crop production, we could, to begin with, we can identify some low risk operations where robotics could be used as an entry point. Because if you think about planting operation, that's a very risky operation. When I say risky, like it might not be directly ready for full automation, but something like, soil sampling, or if you want to do cover crop planting. So which are auxiliary operations, if you want to think about that way, which are not very time sensitive. So those are the places where I think we can really introduce automation to help out with the overall farming enterprise. So like, how does it add value to the farmer? So that's what I think about when I'm looking at automation, and what are some of the opportunities and some of the problems that robotics can solve. Yeah.
And there are things that I guess farmers, thinking about cover crops, farmers are trying to fit in to their operations, right? And it's not something, maybe that is the issue, is the time factor is what's preventing them from maybe adopting those cover crops. Is that one of the advantages there?
Yeah. I think talking to some of our producers, collaborators, they're like, can I have a robot that can follow our combine when we are harvesting? And can we do cover crop planting? Can we do intercropping? So again, all of these take additional labor, but if there is an autonomous system that can help solve it, I think that's a big win-win for both robotics technology and the producers. So
sure.
Yeah, so I guess my experience is less with kind of the large row cropping systems, but more with sort of specialty crops or other agricultural products. I'm working a lot with aquaculture and forestry and kind of fruits and vegetables, and even breeding programs. So I guess when I think of challenges and where thinking of robotic solutions is useful is where there is, at least where I've experienced in, is either the task should be automated, where it's either a labor issue or it's very challenging, or it's labor intensive process. That's kind of a key thing where automation can come into play, or also where maybe you don't have the data necessary to make key management decisions. And so filling a data gap, if those platforms can fill that gap easily, I think that's also really useful. So as an example, kind of looking at coastal aquaculture, we have a project ongoing now to use robotics to monitor water quality, where that monitoring hasn't really been happening, to see if we can better identify and predict when closures might happen due to poor water quality, to better equip aquaculture producers with the tools to decide whether or not to make key harvest decisions for things like oysters and shellfish. And then the other project that I mentioned with Liability pine, if you can imagine these massive pine trees with hundreds of thousands of bags that people go up in these lift trucks and put every single bag on and tie it by hand and go up there multiple times in the season to do controlled cross pollinations to produce seed. That's an extremely labor intensive process. So even, adding in layering automation, if you're not completely replacing the human, that's not always the goal, but it's really developing things that are assistive and either providing key information or reducing costs in some way.
That's I love hearing about, agricultural systems, because I would still consider those agricultural systems in some way, shape, or form, right, that are outside of the norm of what we do out here in Nebraska and in the Midwest. And you mentioned specialty crops there as well, Dr. Young. Would you mind kind of maybe explain to us what some of the differences are in terms of the requirements and constraints that autonomous systems and robots face for navigation, for kind of dexterity, and all these different tasks that they may have to perform across these different environments, and how that affects, how you design them?
Yeah, sure. And that's a challenging question to address, because even within specialty crops, even within a single crop, depending on the cultivation and production kind of style and management style, there's differences, right? Greenhouse versus not greenhouse for some of these things. So, I think in general, the tasks that robotics are being developed for are a little bit different. Like you mentioned, dexterity, so things like harvesting or pruning. We're collecting very high resolution data about shape, color, form to predict yield or predict harvest, things like that. I think the farms tend to be a little bit smaller scale, not always, but a little bit of a smaller scale compared to the large acreage situations you see in Nebraska. So that's a little bit different, but we're trying to make really precise movements and adjustments to image or harvest, a fruit or a vegetable. It's kind of the dexterity and things are at a much finer scale, which is challenging, but then there's trade-offs in terms of, throughput and the types of technologies where you might have a really wide row gap in something like a vineyard or orchard. And so navigation becomes less of an issue. You're not trying to, row keep between really precise inches, but then the dexterity of that manipulator needs to be, super precise and spot on. So I think it's just each system definitely has their own challenges, just very, very different.
Sure. And I guess one additional follow-up question there, in terms of aquaculture, I'm imagining that navigation may be a little bit different too. Are you trying to avoid, fish or, just random, sea creatures that may be in the way out there?
Yeah, that's true. So we're mostly working with shellfish. So they're kind of in these either floating bag systems, or if they're more natural system, kind of at the bottom. So they have different floating systems. So, if they're not on the surface, you're kind of okay, but there's other surface obstacles, such as people recreating or other boats or areas where it might be too shallow. So integrating those different types of navigation sensors to sense above the water and also below is challenging. And this is, of course, for open coastal aquaculture systems. There's, of course, onshore, more closed systems where you can probably have more in situ type of permanent sensors installed. But when we're kind of dealing with these coastal systems, they're very, very dynamic. Water moves. It's not like going on, driving out on a field or something like that. So there's also some interesting challenges there as far as navigation and things like that.
Sure.
Yeah, I can imagine. So going back to Dr. Young and Dr. Pitla, I will ask you a question in just one moment. Just curious, for those unfamiliar kind of with aquaculture, is there anything like commercially, or people using robotics, or is this kind of just like research based?
So, that's a really good question. This is also a space that I've kind of been introduced in the last year or two. So, but once we kind of got this project up and running, being familiar with others working in this space, it's definitely coming up to speed, I think, where other agricultural, technologies kind of have been in the past, 5 years, 10 years. So there's definitely folks working on this space. We've met with companies in, for example, Canada or like the Northeast, where there's a lot of aquaculture production, and they're developing, drones for collecting samples. They're kind of the same thing we're working towards, water quality monitoring, food safety and health type of things. Very new companies. Typically that process is, going out and taking grab samples. So automating that sampling process is something that agencies and producers are interested in. And then I met with a couple kind of entrepreneurs who are interested in developing like robotic systems that actually have the method in which the oysters are grown is actually mobile. So you can kind of sense and predict where the better places might be for, salinity, temperature, those factors that affect growth. And you could actually kind of actuate and move sort of like floating barges. So kind of larger scale robotic technologies. Because it's also interesting, oysters early in their production can be in places where water quality is actually poor, and they can help filter that water. And then as they get closer to harvest, you move them into areas with better water quality so that they don't have any food safety issues. So there's some interesting kind of automation as far as the movement and production of oysters in these larger scale systems. So I think it's a place where there's a lot of innovation kind of happening, at least that I've seen, kind of starting up. And I think we'll definitely see that ramp up in the next couple of years.
Yeah, that is super interesting. And, those who aren't familiar with aquaculture, I'm sure will really enjoy like hearing about that. But Dr. Pitla, can you share with us kind of the extent of autonomy commercially available in row crop systems right now?
Yeah, so, I think if you look at both crop and animal systems, robotic milking stations are probably the most matured, they've been around for a while. But in terms of row crop production, I think it's still in the early stages. There's a lot of startup companies in this area looking to have robots for weeding, primarily, especially with herbicide resistant weeds. They basically do targeted spraying or actual mechanical operation to remove weeds. But I think the big OEMs, I don't know if you saw recently, John Deere advertised their autonomous tractor, fully autonomous tractor. And then Case New Holland, in collaboration with Raven, they have a DOT platform. So that is a robotic platform. And then they call it Omni Drive and Omni Power, I believe. So those are the other two systems. Another interesting company is Sabanto Ag. They have swarms of tractors that can do tillage, that can do planting. So this is all within just last 1 year. I've seen all these trends, so I think definitely the next 5 years is going to be a lot more different. So hopefully we'll see more and more robotic technologies mature and farmers actually get to use them. So
yeah, we're seeing a lot of growth. I mean, you mentioned the autonomous 8R tractor from John Deere. You mentioned Sabanto, who we've had on the podcast here. One of the things that I kind of wanted to ask today, with both of you kind of being in an academic position, what does the interplay between academia and the private sector look like within autonomy and robotics? What do you think it should look like? What does it look like today? And how can it best be leveraged to improve outcomes for farmers? Maybe we'll start with Dr. Pitla.
Yeah, so my philosophy is, whether we are in academia or industry, or ultimate customer is the producer who uses these technologies on the field, right? So always with my research, I look at use-inspired research. So talking to producers, what are the bottlenecks, or if there is going to be a robot on the farm, what are you going to use it for, right? So if a robot can save time, and time is money, right? So which operation would that be? So that's where I start, asking questions about, if I can do this research, how is it impactful? When I do that, this also aligns well with what industry is looking at, right? So because ultimately, again, the end user and customer is the producer, right? So I think that's where, as a researcher, if I align more with what is needed on the field, that I can build more synergies with the industry while contributing to the scientific community also, so the new things that we learn. And I'm very interested in applied research. There is very fundamental research and applied research, and I'm very interested in applied research. So that's how I think.
Sure. So, I mean, I guess, there's a lot of different models that exist out there in the academic industry world, right? Whether it's funded research by industry or collaboration with industry. There's, depending on what the goal is, but at least, that probably varies depending on what your research is on for sure. So from my perspective, at least the kind of problems and things that my group works on and my students work on, I think are a little bit farther out. So I like to think of the technologies that we're developing kind of in seeing a problem, and maybe we're trying to, for example, the pollination project is just a good example where being the first to kind of explore this space. And I think we can learn a lot of things where then maybe we get to a certain point and collaborate with industry, and they, take it and really get it into a format that is commercializable, right? But a lot of that kind of fundamental work has been done. So kind of keeping that forward-looking vision, having a little bit of freedom to experiment and pursue things that may or may not be what the final, on-farmer type of technology looks like, but kind of pursuing things from that research perspective. So, just as an example too, we were working with a tech company that was interested in understanding like this whole problem of aquaculture, because they know ag tech is important, and they kind of wanted to lay the infrastructure and be prepared for when a lot of tech develops in that space. So it's kind of just working and engaging with industry partners and exchanging information is kind of on the way that we've approached it. I think, in academia, depending on what your research group does, industry is very, very good at getting things commercially ready and doing kind of that type of research. And it's been fun to have a little more explorative freedom for some things as well. So I think there's been some complementary work there as far as collaborating with.
How do you envision extension supporting like the integration of autonomy in agriculture production or aquaculture production, industries like that? So I think we'll start with Dr. Young on this one.
Yeah, sure. So, I mean, I think in general, extension is extremely critical, and being that link between, research and stakeholders. And I think that role can be different depending on the technology, whether it's technology that's commercially available and they provide information about whether or not to adopt, or if so, how to use that technology to best provide value. Or if it's, I've given some presentations on pre-COVID on, what technology is out there kind of, as was mentioned in the startup space, right? Like what to prepare for in the next couple of years, what to keep an eye open for. So that's more of like an awareness information kind of position that extension holds. But I think no matter what kind of where that role is on that spectrum, I think, it's extremely important to keep folks like that engaged. I think in research projects, we probably both have or partner with extension personnel or growers or things like that to make sure we're not developing these technologies in a bubble, right? That's not good for anyone. So I think bringing those folks in and stakeholders in from the beginning, even if you don't expect that technology to be, ready in the immediate future, I think it's really important to have everyone involved from the beginning.
Yeah,
I think it's all super, super interesting. I think the way that extension is going to have to kind of reinvent itself over the next, 5 to 10 years is going to be really interesting as autonomy and more of these digital technologies start to affect the farm gate and maybe the fish gate a little bit more. But we're kind of getting into a more fun part of the interview here, where we start to think a little bit more futuristically and not so much about, what is kind of the current state of things, but where can autonomy go and what opportunities are available. And one of the first questions I'd kind of like to ask in that vein of thought is, what are some of the key resources or fundamental improvements that we really need in order to either increase the speed of autonomous technology development or make autonomous technology more commercially viable, kind of take that next step to either allow autonomous machines in the field while a crop is standing, or maybe have maybe mobile fish aquaculture, no longer confined like oysters, right? But actually being in an environment where you have mobile organisms. So I guess Santosh, we can maybe start with you here. But
yeah, so at least for me in the row crop production world, so I think some of the key elements today in autonomy is, your RTK GPS and some sort of camera or LiDAR technology for perception. But I still think that we need more information in terms of the 3D environments that the tractors are working in or the robots are working in. Almost like you need to have a good 3D model of the farm, so that we could do fully autonomous operations. And also, I think farmers have multiple fields. It's in a farm. It's just not one field, right?
Right.
The robots have to go from one field to another autonomously. So how does that look like? I mean, it's talking about future, right?
Mm-hmm.
So you have autonomous tractors, you have maybe autonomous cars, right? So how do they interact? Like when your autonomous tractors are going from one field to another. So all these, there are a lot of fascinating questions, and but are very important to realize these fully autonomous farm or fully automated tractors. So
I think the interplay between field navigation and on-road navigation is really interesting. I hadn't really thought of that before, but you think about how often tractors are used for hauling grain, even or just doing anything kind of moving on a roadway. That safety factor is incredibly important.
Yep, exactly.
So awesome. And Dr. Young, how about you? What are your thoughts here?
Yeah, I mean, fully agree with just, the need for advances in kind of perception across different dynamic environments. No two fields are the same, two farms are the same. That gets exacerbated when you have specialty crops, those types of things. But the comment about off-road vehicle interaction made me also think about the aspect of kind of human automation interaction, human robot interaction, whereas these technologies get smarter and maybe go longer and longer, being able to operate on their own. What does that interaction look like? What level of autonomy do they have? How involved is the human? I think it's important to keep in mind that these technologies, at least I don't think the goal is to completely remove the human from the process, but to rather complement, and maybe, what type of alerting systems, how involved should they be in terms of communication with the human operator? What happens when a system fails? I don't know. I don't have a Tesla, but for people who do, they're not as straightforward to fix as maybe older mechanical vehicles. You have to take them in, get them serviced in this digital world. So I think some of those are also interesting questions where making sure that people are not, frustrated, or that they're able to get value out of these technologies as their capabilities improve. And designing automation, I think, is going to be a key. Designing human automation interaction, I think, is going to be a key part of that.
In that human machine interaction space, are you seeing a lot of research going on there? Is that kind of like an underdeveloped area of research, in your opinion?
Yeah, I'm not sure I'm fully confident I can speak on the entire field, but at least from what I've seen, probably more so. I mean, there's an extremely rich history of literature in this for airplanes and cars, right? Like human interaction with autopilots and all those things with control rooms. So that's definitely been an active field of research for quite some time. I'm just not sure how active that type of research is in the agricultural technology and automation space.
Oh, thank you.
Do you have anything to add?
Yeah, just I agree with Sierra. There is so much about human robot interaction fields other than agriculture, but and then we are actually working on a project related to that. Is can we use gesture control to work with robots? Especially, how do a field producers in the field, let's say if you look at a vegetable operation, right? So if they're picking vegetables and they want to summon a robot to come to them to pick up vegetables, so wouldn't it be nice to have like a gesture control where you wave at the robot and it comes, so that's a active project that we are looking into is using machine vision. Can we identify hand gestures, like typical hand gestures, and convert that into robot commands? So yeah, but then in the future, I think I agree with Sierra, like human has to be in the loop, right? The cobot situation. So how do they all seamlessly work together, to improve the efficiencies is going to be very important.
Yeah, that is really interesting perspective and take on that. Are there any concerns with like autonomy and robotics functioning in the agriculture space? Not necessarily the adoption of those technologies, but like actually functioning in those spaces?
Yeah, I think safety and liability, those are all really important, especially if you're talking about big machinery, right? So 300, 400 horse tractors, fully autonomous. So we really need to have redundant safety systems. And then
Yeah, I mean, I think some of that depends on what the application is. If it's an application where you need some type of labor assistance, well, then that might be directly replacing the human for that specific task, but then you likely still have people observing, monitoring, kind of there for that operation. Or if you're, have the person removed from it completely, I think there's kind of different scales for the level of involvement that might be needed depending on the task. But I mean, as far as this goes, I kind of agree with everything that's been said already as far as ensuring safety and liability is an interesting question. I think one thing that's good is that we have the autonomous kind of vehicle industry going ahead of this. They've been doing this for a little while, and there's been, I think there's going to probably be some precedent that could be useful as far as, what happens when there is an accident. How do you determine if it's user error or if it's the fault of the company developing the technologies? We've seen this with some of the vehicles where people pretend like they're fully autonomous, but they're not intended to be used that way, right? So ensuring that things are being used in the right way is also going to be, I think, an important part of this as well.
Sure.
What's kind of your vision for autonomy, robotics, and specialty crops, agriculture within, kind of like a 3-year vision? And then if you have a 10-year vision, kind of share that too.
That's a really good question. And I don't know if my vision is the right one. I'm sure this will vary depending on who you ask. But I think what I'm most excited about is that, we have all these startups, all these folks working in the space. I think it would just be really awesome to get more platforms in the field tested across diverse kind of operations. You sometimes see these one-off case studies or small scale testing, just a few adopters, but I think it would be really neat to see for the things that are commercially available, just kind of more adoption, at least in the short term, to see, accelerate that development period, right? Where you learn more, the more you use these things. And so I think that will be, I think for some of these technologies are at a critical point where it'll just be really cool if more folks start using them and hopefully they work as intended. I think some of that's probably a little bit of an unknown. I guess right now I feel like we're at this point where there's so much potential. So it'd be cool to see some of that potential start to be realized.
I think that's a really good point. I mean, the point about actually having to use something in the field to know how it works is, I think, so critical and often missed. I think there's kind of this perception out there amongst adopters that you need to have everything figured out before it gets to the field. And it is kind of this fine line, right, where you need to be able to offer something commercially, provide value, but at the same time, in order for it to really get out to scale commercially and get correct, it really needs to be picked up and used to some extent. So it's a delicate balance.
For sure.
Santosh.
Yeah. So for me, I'll start with a 10-year vision. So, imagine like swarms of robots working in the field, solving the most pressing issues, like let's say targeted weed management and soil health management, which involves crop planting, and co-working with the producer seamlessly with no technical hangups. I think that's what I envision 10 years from now.
Wow.
I think in the next 3 years, I think if we have a very user-friendly robot that could do some mapping of problem areas in the field, and then cover crop planting in the field, just even a single robot, but the ability for farmers to actually getting used to the technology and doing it by themselves in the field and amplifying what they can do. I think that's kind of what I have with one robot, in the next 3 years,
Yeah.
and then extrapolate it to multiple swarms, and modular machines. So
Yeah. Your mention of mapping, I think, is really undervalued.
Mm.
Are there some management practices that you think are possible with robotics that are not currently possible with manned machinery, that you could see farmers getting into? I mean, we've mentioned cover crops, but are there some other opportunities that you've seen out there for robotics to expand management opportunities?
Yeah, I think very highly precise specific nitrogen management could be another thing. If you have a AI enabled robot that is looking at the current state of the nutrients on the plants, and be there in the field 24/7, applying very precisely, goes back to the fertigation aspects. Very similar. If you don't have pivots in the field, you could be using the robots doing nitrogen management. So
Sure.
that's something I think is very timely and very important given the fertilizer costs, and then the issues we are having with runoff. So I think that'll be a great application for one of the important management practices in my view.
Sure.
Mhm.
Yeah, it's really interesting. And Dr. Young, for you, have you noticed any like management practices as people have maybe seen some of these autonomous vehicles, entering their environments? Have you seen any management practices that people are like, oh, I could use that for this, or that you have just identified yourself as being an opportunity out there?
Yeah, I mean, I think one space that is, viable now is using advanced sensors that can see things that we can't see to understand kind of what's happening from a crop physiology standpoint, like disease, early disease detection. It was just mentioned, nutrient deficiencies, things like that, to where you might be able to do those things in a more timely manner, in a more precise manner. So kind of piggybacking off what Dr. Pitla just said. And so, also using these for new things. For example, we just had a paper out using hyperspectral imaging to differentiate between hemp cultivars and growth stages. And management in hemp is really interesting because if you manage it in such a way that the THC content exceeds like the legal threshold, it's problematic. So, and that can be a function of management, also genetics and growth stage and the cultivar itself. So if you can start to use technologies to better understand kind of what's happening in the field that you might not be able to tell kind of at all, just walking through, manual looking and scouting those types of things, kind of assisting with making those types of decisions about harvest or application using these sensors and AI models that can help make those types of predictions.
So if someone wanted to learn more about your research and what you're working on with autonomy and agriculture production, where can they go to find out more? And we'll start with Dr. Pitla.
Mainly, I have a Twitter page, Santosh Pitla, but UNL's BSc webpage, you should easily find me there. So
Cool.
Awesome.
And Dr. Young?
Yeah, same. Big on Twitter at Sierra N Young. So you can follow me, try to keep everyone up to date on what's going on. And then of course, web pages with the university, or if you have any questions, also feel free to email me, just sierra.young@usu.edu. Happy to communicate that way as well.
Fantastic. So one of the things we like to do here on the FarmBits podcast is wrap up every interview with a piece of advice. And so the piece of advice that I would ask from each of you today is, what advice do you have for our listeners who are either interested in adopting autonomous technology into their farm operation, or for those out there who are interested in pursuing a career in this field, what advice would you give to them for getting started and kind of heading down that career trajectory? And Dr. Young, I think we'll start with you here.
Sure. So I'm going to tackle the second question for folks interested in working in this space. So my first piece of advice would be to just kind of get your hands dirty. See if you can find someone working in the space or be familiar with the technology, get yourself a hobbyist drone, buy an Arduino, get familiar with sensing. I think that's the best way. That's how I got interested in it, was having really no experience and kind of diving headfirst into this. You learn a lot and hopefully get excited and motivated along the way to take any next steps, whether that's a professional degree or kind of a career change move. I think just getting involved and not being shy to reach out if it's something that you don't feel like you have experience in, because I think you'd find a lot of people are really excited to share their expertise and knowledge with anyone who wants to come listen and be involved.
Yeah, I think you made a really good point there about the Arduino, just how accessible some of this technology is to just pick up and get your hands on and start working with. I think that's a really good point. And Dr. Pitla, what is your advice?
Yeah, to that question, I think, agriculture is transforming at a really fast pace or evolving, and technology is key for future sustainability and, food security, energy security, and so on. I think this is a very dynamic space, and I think this is a great program to get into agriculture engineering. Going back to Sierra's point, tinkering and maker spaces, there are great places to start, and then get a professional degree in this area. I think if you're really looking to contribute to have an impact, at a global and a local scale, I think this is a great program to get into, like agriculture engineering.
Thank you very much to Dr. Sierra Young and Dr. Santosh Pitla for joining us today on the FarmBits podcast. It was really interesting to hear kind of an academic perspective. We've had a lot of industry perspectives so far in the series, and so it was good to get their take on automation and robotics. A couple of things that I thought were really interesting. Santosh mentioned kind of the interplay between on-road and off-road capability for autonomous vehicles in agriculture. So thinking about if you have to have machines navigating between fields, being able to have kind of road safe operations as well as field safe operations is a whole another level of autonomy that hopefully we will be able to borrow a little bit from the autonomous car industry, vehicle industry for that. But I thought that was really interesting. And then also some of the specific applications that he thinks robotics may be able to have here in 10 years, plant specific fertilizer management, for example, or having dedicated 24/7 robots in the field. I think those are just kind of really interesting ways of thinking about production agriculture that maybe definitely are not unlocked with our current technology and capabilities on the farm.
Yeah, I think it was really good perspectives from getting an academic perspective versus our industry that we've had before. Really important. I agree to have, safely traveling, robots from field to field. That was a really good point. I really enjoyed learning and hearing about how much autonomy and robotics can be kind of applied in every aspect of agriculture and, aquaculture, even to forestry, like Dr. Young's student is now working on. And I think the potential for, extension to kind of jump into robotics now and moving forward in academics is really going to be helpful into making autonomy and robotics kind of accessible and really implementing it on operations.
Yeah, it'll be interesting to see how extension has to change to kind of fill this need.
For sure. Well, thanks for joining us today on the FarmBits podcast, and we look forward to talking with you next week. Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback. So if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.